Welcome back to Designing AI-Driven Personalized Learning Environment course. In 3.2, we will talk about learner model in PAL. Why we need learner model? I think we talked about it in the last video, but we'll go in detail why we consider this learner model, how are you going to adapt it. So recollect this problem we saw in the rule-based model, I think in last week. There was a geometry tutor where given the angle A is 65, can you find the angle C? In this problem, we know the triangle is isosceles triangle, which means two sides are equal. When two sides are equal, given the AC and BC, angle A and angle B will be equal. So I assign angle A to B. The first rule is angle B will be 65. Then you go to another triangle property where sum of the all angles is equal to 180 degree. This is very basics. We saw this, how the rules are created. I think the rules are also here, the same isosceles triangle ABC. These details are here. Now, why we need learner model? Do you think we need learner model first? If yes, why? Why we need learner model? Because in the previous rules, it is very clear there is a isosceles triangle, there's a two set of rules, everything is clear. But why we need a learner model? It's enough. We can give the problem in this. If students have an issue in understanding the property of isosceles triangle, you should give the feedback there. If the students have a trouble in understanding, the triangle property of adding triangle is 180, you should give the feedback there. Why we need to know about the learner here? So think about it. If you think we need a learner model, please write down why we need learner model. If not, also why. Pause the video for a second and continue. So in a classroom, the tutors have the ability to track students' cognitive skills and provide adaptive feedback based on their performance. In a classroom, the tutor is also observing what feedback or what response student providing. Based on that, they give a feedback. There's a feedback, but they're not giving a fixed set of feedback. Instead, they try to understand the students' responses for the last 3 questions, last 4 questions, try to understand why the learner is doing it and try to give a remedial content. For example, if you add this sum, I think we did it last time, if somebody enters the denominator is 14, the rule-based model would say in the fractions in the last video we saw, it will say that, hey, you are adding the denominator. That is one of the buggy rule. It gives the answer. Your answer is wrong, you have to do. So that is the system can give also. But we need to know to model the learner skills by intelligent tutoring system. The most important adaptive tutoring is called skill modeling. We need to understand what is the student's skill in this particular sum. If the student have an issue in converting the fractions into equal fractions, or the student having skill in adding two numbers, or does the student understand what is meant by fractions? So to understand this, we can't only take, hey, the student response is 14. I need to know student's continuous response. Then a student's prior knowledge in addition, prior knowledge in the basic fraction, prior knowledge in the like and unlike fractions. If you know those concepts, I can do better in the adaptive content. The given 14 can work for the current set of problem, but it may not be correct for the learner who are struggling what is addition means, what is fraction means. So to understand, we need to learn a model with each concept, what is the student's skill. This is the problem we have to address. Okay, so what we mean is the simple rule-based model can give a feedback. Also teacher could give feedback, but in the teacher we also understand why the student came to this issue, why the student is having this problem. Can we look back their prior skills needed to answer this? Do they have all the prior skills? That is the level of checking which can checked by the learner modeling or skill modeling in this particular parallel. So the problem is that one size fits all, that is with the learner model, without learner model, if I say that, hey, there's a system, here is the digital kind of textbook, it's basically without learner model, student is reading one thing after one. It's basically called, as the term is very known term, called digital pager to page turner. Basically, instead of system without any adaptation, it basically student is clicking as patterns is going on. The system is not understanding why the student is lacking some skill, or the student is lacking any skill, to provide feedback. It will be simple book reader or some of the digital page turner. It's not adapting based on each learner. So knowing when student has mastered a topic, so that we can promote to next chapter. Suppose given a topic, a student's completed the particular topic, so I can move into the next topic called personalization. The student has completed, I want to move into next lesson, the micro level adaptation. I mean, in the last in the last slide we said that we might need a personal data. Personal data is needed for the macro adaptation. A student comes in first time to the system. Student says, I am a third year computer science student, I know Python program already, I know Java program already, I need to learn something new. So based on the student's prior knowledge, their background, their the domain expertise, I can suggest a new language, I can adapt the content directly. That's called macro level adaptation. That's called personalization. But when the student is interacting with the system, and each step, is he using the hint, is the student is, how many hints they used it, the student is using hint, still not able to answer the question, can I give feedback based on, after student using the hint, some feedback is coming. That adaptation is micro level or scaffolding, kind of supporting to solve that problem. I hope it is clear difference between personalization and scaffolding, and this is not a very hard definition. Okay, even scaffolding is kind of personalization. Even scaffolding is part of solution if it automatically happens. But in the intelligent tutoring systems on the PAL, we kind of scaffold within the problem with a set of rules. Okay, the scaffolding happens for all the students based on the hints they used it. But overall, their performance on multiple subtopic is collected. The skill is measured. The skill is used to promote the next topic to them. So there are two levels of adaptation is happening. One is micro level, that is not much of tied to the each individual learner. It is basically the pedagogy on, if the student use this in, give the feedback. The students have issue, give the feedback. Scaffolding is not actually using the learner model content. Wherever to provide the set of next content, to provide based on the mastery, to provide the next set of content, we need a personalization. So for personalization, the learner model is very important in the PAL. Hope it is clear now. The pedagogy comes into the micro adaptation for the expert level. Here also we need kind of one size fits all, but in the personalization model, we need to know why the student struggle. Given the 10 subtopics the student had a misconception, these topics, can I give remedial content? Those things comes under personalization. The another thing is keeping the student in the zone of proximal development by matching the skills and the ability. Suppose a student is having the learner ability of a skill of say 0.6, you can student have this topic 1, he has a 0.6 level of ability. I should give the content to match the students ability. If I give very hard content to students, student will not able to answer it, student will get confused, frustrated, then bored and leave. Or if I give very easy content, student feels it's very easy, I am not learning anything, student might get bored again. So to understand, to give the content to the ability of the learner, we need to understand the learner's learner ability. So we are trying to understand why we need learner model. Of course, we need learner model to understand where the student stands so that I can provide the right content. Of course, I need learner model to understand the skills, their the topic level mastery, everything, to provide the next set of topics. Also, we need a learner model to understand, are they using the right comma hint, are they using the right set of misconceptions. Then we can do micro level scaffolding, also use that information to understand the mastery. So we need learner model to provide macro adaptation, also to keep them in zonal approximation, also to measure the mastery by using the micro adaptations. It's clear, I hope it is clear. Let's assume you are conducting a weekly test to the learner and your system is able to collect action performed by the learner with timestamp. When I say weekly test, consider you are a teacher, or consider you are a coaching institute, or you are some kind of institute where you want to teach a new concepts, maybe programming something. And to measure the learner's knowledge, you are collecting the weekly test. There's a mock test or a weekly test with all the concept you are teaching. Okay, let's consider the topic. You are teaching a topic T1. The topic T1 have T1.1 subtopics, 1.2, T1.3. So I have three subtopics in it. I taught all the three subtopics in the particular week. Now I want to conduct a exam, the weekly exam, to measure the students' knowledge. Okay, is it clear? Now I have the questions in each one of them. Suppose I have 4 questions. So 1, 2, 3. The question 1, 2, 3 tied to topic T1.1. The question 4, 5, 6 tied to topic 1.2. Then 7, 8, 9, 10. So I have 10 questions to it. Also in these questions I have a set of difficult questions, that is easy, medium and high difficulty questions. Suppose this is easy, medium, high, same, something like that. Maybe another thing. Okay, so now I have tagged each question based on the topics, also their difficulty level. I am a test this. I am also giving this test to the learners, and I actually know in a hard topic what concepts in the topic 1.1 I am testing, and I know that level of information. This is very easy to map it. Once we mapped it, we mapped properly the questions difficulty level. Now I am conducting this test every week, say 10 questions or 100 questions. My system is able to collect their response in each question. Is it right? Which option I choose? Okay, wrong, the option I selected, option A, B, C. Also my system is able to record their timestamp when they perform the action. Whatever timestamp, Unix timestamp or any timestamp, you are recording their timestamp of when the action occurred. Okay, imagine you have a system, we have to collect their weekly performance on a particular content you are teaching. You have all the actions they are performing and the time of this action performed is collected. What characteristics of the learner you can model based on the data collected? So you collected 2 data, timestamp and actions. Also each question got type and everything, difficulty level. Assume that you have made a question based on topics, subtopics, difficulty level, this which we discussed here. Now this is a very interesting problem. Please pause the video, note down what are all the characteristics of the learner you can do. We will be seeing only 2 or 3. There can be n number of possible characteristics of learner can be observed only using these 2 features. Okay, so I want to pause the video here and write down all the characteristics of the learner we can capture from these 2 data. From performance, we could understand their out of 10 they performed 6 out of 10. Very good. In fact, you could even go better, instead of simply saying 6, I could classify them into T1.1, T1.2, T1.3. There are 3 questions each, only one has 4. So I could say that in T3.1 they did 2 questions correct, in 2.2 they got correct, only 1 question correct, something like that. I could go back further saying that each topic, what is the student's knowledge also considered. Here we could say, if instead of that you could say percentage, this would be like 66.6% covered. This will be only 25% of the topic answered correctly. Out of 4 questions, 1 question is answered correctly. So 1 by 4 will be, this is out of 3 questions because topic have only 3 questions. This is only 1 by 4 questions because we added 4 questions in the topic 1.3. We could say that students are able to answer questions, well in the topic 1 and 2, they are struggling in topic 1.3. So might need to go remedial content. We could go further. The difficulty level of question again say that the student is able to answer all the easy and medium questions, but they have a struggle in the high hard level questions. So although they answer topic 1.1 and 1.2 correctly, they have struggle in understanding the hard or the real problem, real scenarios, or not able to combine couple of concepts together. I want to teach it better, because you are actually a teacher, you are a coaching institute, you are someone you want to do your students excel in the particular exam. Okay, so you could go again teach again T1 and T1.2 instead of only teaching T1.3. So these are the basic descriptive stats you could collect from this. Let's go with the timestamp you collected. With the timestamp collected, what we can do? Let's consider. So you are a coaching class institute, you are teaching this mock exam every week. You could see that, forget about performance, you could see that what type of questions a student spending more time, what type of students spending less time. You would see that students spending more time in the initial topic 1.1 and 1.2 because they thought they have a time, because the time test. When they came to topic 1.3, they did not have a time. They just randomly cited 3 options and moved on to manage the time. That can be the one. Or you could see some student strategically solving all the known questions first, then coming back and doing the unknown questions with more time or something. Now you think about it. If a student spend the known questions first, this is a strategy, how many known questions a student have a mistake. Now you know that students has a confidence that I know this question, I can solve it in 5 seconds, he's trying to solve it, but there he made a mistake. Now you know that based on the simple timestamp of each, the way they answer the question, the strategy that they will do, plus are they doing it correctly. Now the focus mostly is on a student thinks they would be able to answer the question, but they have a struggle. Which I mean, suppose student answers set of questions, known question, unknown questions. The average time for the known question the student spends is say 10 seconds. The average time a student spends on unknown question is say some 30 seconds. Okay, sorry. This. Okay. Now, within this is the average time. Within that, the student's performance is only 75% correct. You see, the student thinks he knows the question. It might be easy, it might be the very well topic, but students have a trouble. If you consider students spending a lot of time on unknown questions, so I should teach him more time to solve, how to solve it better, but you are missing that the 25% of mark is gone in the known topic itself. They're making some slips, they're making small silly mistakes or something missing in it. Now, simply by knowing the time they spend on each question, the type of content we are doing, we could be able to understand the learner the different strategies. So that is what I mean. Why we need to collect the interaction data and why this learner modeling is important. With the simple 2 data of this time spent and the type of question they answered, we could do multiple things. Here I am not even included the difficulty level or the topic 1.1 here. If I add, it will be more detailed analysis would come. Then we will not able to give a same response to the other learners. We can cluster them in a multiple groups. Then we can provide a different kind of content for each cluster. The next step is even more interesting is that if I get this data, can I do a sequential analysis? Can I do how the students, the pattern of the answers? The student spends 3 questions correctly, then he had a mistake, then is he spending more time after the further questions? Or the student had a struggle in the initial questions, then they had issues. So those kind of sequential analysis pattern also we could analyze. The patterns, clustering, lot of ML methods can be applied just to understand the learners, difference in each learner's behavior and strategy. So I hope it is clear now what we mean by learner model. The learner model is trying to understand students' performance, also the type of actions they performed with a timestamp. This is needed to provide a adaptive content for the each learner separately. If some learner who did 10 seconds on known question, he did all questions correct, I don't give any focus on those questions. I'll focus on unknown concepts of the learner or the time they're spending more. If some learner has done known question but having struggled, I need to focus on the learned question also. This is the two. Here the some learner who has done only easy question, not hard question, I should focus on T1.1, 1.2 also. And suppose the student in T3, he has done the hard question, not the easy question, you don't need to focus much because you're able to understand, maybe he did not have a time. Okay, so those kind of analysis is needed to model the learner, not just a skill based on the behavior, then provide feedback. Okay. Now we will see how the learner model is used in the personalized adaptive learning systems. So here we call as the intelligent learning environments. I was telling it's ITS, PAL, ILE, the different names. Professor Baker and Desmarais created a review on learner models. From that they created this particular nice representation for the learner model. So this is adapted from the particular paper. So what we see is that in a system, in a computer based learning environment, a student can perform multiple actions. The actions can be clicking next button to go to the next question. The student is reading the question. We know that because the student is spending time, when you click the next button, it spends 10 seconds to click the option A, option B. So 10 seconds or 15 seconds is enough to read it. Now some students spending more time to solve the questions. If they ask for a hint, the student is not able to understand the question and need a concept, so you need hint. So we know that each actions a student does in the learning environment, and each action will lead to some kind of outcome. When you click the next button, the system goes on to the next page, which means a student is reading the new question. They're asking the hint, which means they have add more, the hints appears. They understood the particular hint concepts. So when they read a particular PDF or watch a video, they would understand the concept, the student's outcome, also system outcome. So the each action have a certain outcomes. This is you are considered while designing the system. Using this, we have set of observation notes. For example, using this, we know in the system we can record those information and we can collect the data. That information says that the student is reading, the student is performed 8 questions correct, the student has 3 hints, the student have watched a video. Those are the observable notes from that. Then using the data, like last slide we saw that using simple time and action, can I understand the strategy of solving the questions? Can I understand which topic they have issued? This is a hidden layer, right? That is not directly observable, that is derived, constructed from the observable actions. Okay, these are the actions they perform in the system. In the observable node, we say they are reading, they are answering the question, the performance is correct, those kind of actions. Watching the video, they are going back to the video, they are rewatching it. But using those information by combining multiple of these features, we construct a new feature saying that the student have a strategy of doing the easy questions first, then go to hard question. The student have a strategy of solving the topics in a sequential order. Students have the struggle in the engagement. Student have some other misconception or the planning issue. Those things can be observed in hidden layer. There's an above layer, it's even more more difficult. They try to understand students' thinking skills, metacognition. How are they planning? What's happening in the brain when they are doing this? That's a very higher level. So most of the ITS we see is links only with this observable nodes. We can do some of the constructible nodes in the hidden nodes layer. But for the simplicity of this course, we will keep only till the observable nodes kind of actions. We will not go to the strategy. We will not go to the sequence of actions to understand the strategy. That's not the goal of this particular lecture or this particular course. So we will consider in the person's adaptive learning environment, students performing actions in the computer-based learning environment. We know what are the actions they are doing. Okay, within that, can we adapt? Can we provide a personalized content? Okay. So to explain the last what we discussed in the last slide, learners' observable actions listed in lower level can be directly mapped to the nodes of learner model. Action outcomes to one level above or observed outcomes inform the student state. Are they reading? Are they watching video? And that can be described. What are they doing? And they watch the video. They read the video. Read the page for 5 minutes. Something like that. The sequence of actions and the outcomes, it can be combined to provide a more hidden kind of a layer that is very important later. Okay. So thank you for watching the video. I think in this video we try to explain why we need this learner modeling in the PAL. We need it for the macro adaptation, to keep them in zone of functional development, also for micro adaptation. Also we need this to understand the strategies, the performance, and to provide the proper content. Okay.